This is GATE 2011 question number 37, which states that a spherical conductor of radius A is placed in an uniform electric field E is equal to E naught K cap, where K cap is the direction which is shown here. The potential at some point P having at position R and theta, where R is greater than A, is given by this particular formula, where R is the distance from the distance of P from the center O of the sphere, and theta is the angle that OP makes with the Z axis. The charge density on the sphere at some theta is equal to 30 degree is. So the main motive is to find out the charge density of the sphere given this kind of a potential of the distribution. So let's come to the solution. So it is given that the spherical conductor of radius A, let me change the color. Yeah, spherical conductor of radius A is placed in a uniform electric field given by E is equal to E naught K cap, and this is the K cap direction which is shown. Now potential at P R comma theta, that is phi, this potential is constant minus E naught R cos theta plus E naught A cube by R square cos theta. This is given in the question. R is the radial distance from the center O of the sphere, and theta is the angle which this OP makes with the K cap direction or the Z axis. We need to see that this E is always in the radial direction. E does not change in the theta as well as in the phi direction. E is constant, uniform, but in the radial direction. This K cap is Z axis, which is representing one of the radial directions, because if we just see the spherical polar coordinate and make a particular quadrant, so this is suppose one of the quadrants, and this is suppose the Z axis, this is X, this is Y, and this is your R. So you can see that this is also one of the radial directions. This is also one of the radial direction, and your electric field given in this question is in the K cap direction, that is in towards the Z direction, which is nothing but one of the radial directions. So this is what we have, and this is in one of the radial directions. So we don't need to understand the theta and the phi direction variation in the electric field. So to find the charge density is our main motive. As I have told, that theta is 30 degree, which is fixed at particular theta we need to find out. Now this is the spherical conductor. So for spherical conductor, we know, or for any conductor, we know that the electric field is nothing but sigma by epsilon naught, where sigma is nothing but the charge density, charge per unit area, charge density, and epsilon naught is the permittivity at free space. So sigma becomes epsilon naught into E, and we know that this electric field is nothing but negative gradient of potential. This is known to us. Electric field is negative potential of gradient of phi. So minus grad phi, we can directly write E as minus grad phi, where phi is the potential. Now this grad phi in the spherical polar coordinate can be written in terms of R, in terms of theta, and in terms of phi. Everything can be written, but we will only choose so this will be actually delta phi by delta R. This becomes plus 1 by R delta phi by delta theta plus 1 by R sine theta delta phi by delta lambda. So lambda is this particular direction. This is the particular direction of lambda, suppose. So this is how it is defined. But as we know that we know that electric field is varying only in the R direction. So therefore we will just put delta phi by delta R. It is not varying in the theta direction, or because grad phi is actually representing the electric field, which is only varying in the R direction. So we need only delta phi by delta R. We don't use delta phi by delta theta or delta phi by delta lambda. So sigma becomes minus epsilon naught delta phi by delta R. So I have written here only delta phi by delta R because E is in the K cap direction, which is one of the radially outward direction. It is not varying with theta. It is not varying with varying in the theta direction or in the phi direction. So E not varying or not changing in theta or lambda direction. So therefore we are not using it. We will be using only delta phi delta R. So if we do delta phi delta R, we get minus E naught cos theta minus 2 E naught A cube by R cube cos theta. This is what we get by differentiating the potential with respect to R. Now at theta is equal to 30 degree, cos 30 is root 3 by 2. So that is what I have written here. at every theta points, because at fixed 30 degree we have to find out the potential, the electric field, and we have written it. And on sphere means R is equal to A, just put it down and we get A cube cancels out, and there is a minus sign already in the outside. We multiply it, it comes out to be epsilon naught E naught root 3 by 2, 1 plus 2, that comes out to be 3 by 2 root 3 epsilon naught E naught. This should be the answer, 3 root 3 by 2 epsilon naught E naught. Option A is correct. Let's come to the question again. 3 root 3 epsilon naught E naught by 2. This is the correct option for this particular question. Thank you.